In this lecture, we'll look at the expected value rule, and then separately we'll look at the linearity of expectation. How linear can expectation be? And so with this, we're not going to spend a ton of time on these two in derivations or proofs. We're really just going to look at the formulas and understand them and know that we'll need to use them again in the future. So the first one we'll kick off with is the expected value rule, which basically says that if we have some random variable x, and that x has a probability mass function, or a PMF, associated with it, that is the PMF of x, and then we have some random variable y that is a function of x. We'll call it some g of x. Then we can write that the expected value of y is the expected value of that function of x, that g of x, which makes sense. Now, where this becomes beneficial is the ability to translate an expected value of y to really something that iterates over x. Now, you may remember that if we look at the expected value just in general, we would say that the expected value of some random variable y is equal to the sum over all possible values of the random variable y of the specific value, lowercase y, multiplied by the probability mass function for the random variable y at the specific y. So again, we're saying what is the value and multiply that by the frequency of that value, and that gives you the expected value of some random variable y. Now, as you'll notice in this equation, this sum here is over y, but maybe we want to sum over x instead. And in this case, as long as our y is a function of x, it's some g of x, then we can utilize this expected value rule to our advantage, which says that the expected value of y is actually equal to the sum over x, over all the possible values of x. But what we do then is we take the function and apply it to that value of x. So we're using g of x in this case as our value, and we multiply that value by all of the possible outcomes of x, not of y. So basically by inserting this value here, this function more accurately, of each value of x, we have now moved our iterator to be over x instead of y, which is super beneficial a lot of the time when you're looking at expected values. And again, this is the expected value rule. So one of the things to keep in note, though, just as a generalization, and sometimes this rule isn't necessarily true, but in general, the expected value of a g of x, some function of x, is not equal to that function applied to the expected value of x. I'll say that again. The expected value of a function of x is not equal to the function applied to the expected value of x most of the time. Now, the next thing we'll look at is linearity of expectation, and this basically says that if we have a random variable x that has a PMF associated with it, that we can say that the expected value of some constant, let's just say it's a, multiplied by the random variable, you can move that constant outside of that expected value. So this is now the expected value of a constant times a random variable is equal to the constant times the expected value of that variable. Again, this is one of those things, if your function is just multiplied by a constant, well, then you can move the constant outside the expected value. But this is down to the linearity of expectation. We can say that if there is a inner multiplier or a linear argument internal, if the function is linear, then we can move that outside of the expected value, as you can see in this type of an example here.